Anna's hummingbird is small enough to fit in the palm of a hand, yet it operates at the extreme edge of what biology allows. Every movement, every breath, and every heartbeat exists near a physiological limit. This bird does not live slowly. It survives through constant motion. Scientifically known as Calypt Anna, Anna's hummingbird is native to the western regions of North America. Unlike many hummingbird species that migrate long distances, this species has expanded its range and adapted to year-round life in temperate climates, even enduring winter conditions that would kill most birds of its size. Its appearance is unmistakable. The male's head and throat shimmer with iridescent pink and magenta feathers, known as a gorget. These feathers do not contain pigment in the traditional sense. Instead, microscopic structures reflect light, creating color that shifts with angle and motion. In shadow, the bird appears dull. In sunlight, it explodes into color. The body is compact and aerodynamic. Wings are long relative to size, attached to powerful shoulder joints that allow an extraordinary range of motion. Unlike most birds, hummingbirds can rotate their wings almost 180 degrees, enabling flight forward, backward, upward, and sideways. Flight defines the hummingbird's existence. Anna's hummingbird beats its wings up to 50 times per second during hovering. During courtship dives, wing beats and speed increase even further. This motion produces the characteristic humming sound that gives the group its name. Hovering is energetically expensive. To sustain it, Anna's hummingbird maintains one of the highest metabolic rates of any animal. Its heart can beat over 1,000 times per minute during flight. Oxygen consumption is extreme. Fuel must be constant. That fuel is nectar. The hummingbird's long, slender bill and extendable tongue are perfectly adapted to extracting nectar from flowers. The tongue splits at the tip, forming grooves that trap liquid through capillary action. This is not simple licking. It is a rapid, mechanical pumping process. In addition to nectar, Anna's hummingbird consumes insects and spiders. These provide protein and essential nutrients that sugar alone cannot supply. Feeding occurs almost continuously throughout the day. Because energy demands are so high, the bird cannot afford interruption. Territorial behavior reflects this reality. Males aggressively defend feeding areas, chasing away rivals with sharp calls and high-speed pursuits. Courtship behavior is one of the most dramatic displays in the bird world. Males perform steep aerial dives from heights of up to 40 meters. At the bottom of the dive, air rushing through tail feathers produces a loud, sharp sound. This sound is not vocal. It is mechanical, created by feather vibration. Females evaluate these displays carefully. Speed, precision, and sound all signal fitness. Only the strongest and most efficient males succeed. Breeding responsibilities fall entirely on the female. After mating, the male plays no further role. The female builds a nest about the size of a walnut, using plant fibers, spider silk, and soft materials. Spider silk allows the nest to stretch as chicks grow. Eggs are tiny, usually 2 per clutch. Incubation lasts about 2 weeks. Chicks hatch blind and featherless, entirely dependent on the mother. Feeding is frequent and demanding. Growth is rapid. Within weeks, chicks develop feathers, muscle strength, and coordination. The first flight is critical. Failure means death. There is no margin for error at this scale. One of the most remarkable traits of Anna's hummingbird is its ability to survive cold nights. To conserve energy, the bird enters a state called torpor. Body temperature drops dramatically, heart rate slows, and metabolism decreases. At dawn, the bird must rewarm itself quickly to resume feeding. This adaptation has allowed Anna's hummingbird to expand its range northward, even remaining year-round in areas once considered too cold. Urban environments have played a surprising role in this expansion. Gardens, ornamental flowers, and feeders provide reliable food sources. The species has learned to exploit human-modified landscapes without becoming dependent. However, this proximity brings risks. Window collisions, pesticides, habitat loss, and climate instability all pose threats. Because of their size, even small disruptions can be fatal. Despite this, Anna's hummingbird remains resilient. Its intelligence, memory, and spatial awareness allow it to remember feeding locations and schedules with remarkable accuracy. Ecologically, the species is a vital pollinator. As it feeds, pollen transfers between flowers, supporting plant reproduction. Many native plants rely on hummingbirds for survival. The relationship between flower and bird is ancient. Shape, color, and nectar composition evolved together with hummingbird feeding behavior. This mutual dependence highlights the complexity of ecosystems at even the smallest scales. Anna's hummingbird challenges assumptions about fragility. It is small, but not weak. Fast, but not careless. Specialized, yet adaptable. Its entire existence is a balance between abundance and starvation, speed and exhaustion, exposure and control. There is no pause button. If this bird disappears, the loss would ripple outward. Pollination patterns would shift. Insect populations would change. The absence of its high-pitched presence would leave a silence disproportionate to its size. Anna's hummingbird proves that survival does not require size or strength. Sometimes, it requires precision, memory, and relentless motion. In a world that often values scale, this bird thrives at the smallest possible margin. And in doing so, it redefines what power looks like in nature.